The recent tragedy at Grenfell Tower has once again focused Britain's attention on the devastating consequences of a major fire. 71 people died and over 70 were injured. In order to prevent fires both large and small, it's clear that investing in fire detection technology is crucial. The aim of this film is to demonstrate that technologies exist now that could radically increase the efficiency with which we respond to fires, improving both life safety and the protection of property. We believe the time is right for these technologies to replace outdated systems in higher risk applications such as high-rise residential buildings and commercial premises. Research shows that early detection can play a vital role in ensuring that when a fire starts, occupants can exit a building in good time before it has an opportunity to escalate out of control and become life-threatening. This improves the likelihood of intervention by the fire service being effective at minimizing impact on the property and the function it supports. When it comes to tackling a blaze, every second counts. Within just a few minutes, a fire can grow from a manageable incident into an emergency situation. Automatic fire detectors are the best way to provide early warning to occupants of a developing fire, enabling the fire and rescue services to arrive on the scene and become involved as soon as possible. A fire starts. The alarm is automatically triggered, sending an alarm signal to a monitoring center. The operator alerts the fire and rescue services,
Fire and rescue,
who should dispatch a crew to arrive at the scene as soon as possible. But there's a problem. The vast majority of alarm signals generated by automatic fire alarm systems do not relate to an actual fire.
Automated fire alarms are by far and away the largest bulk of our false alarm calls.
We see that 96% of alarm activations are false. We are passing calls out to the fire and rescue service, and we take steps ourselves to prevent those false alarms being passed.
So that more and more we're able to try to discern exactly what's going on before we make an attendant.
False alarms are caused by the inability of traditional detectors to distinguish between innocent stimuli and genuine indications that a fire has started. For example, treating shower steam as if it was smoke. There are also unwanted alarms. These are caused by detectors which can't differentiate between safe and dangerous signals of combustion. For example, treating cigarette smoke as if it was evidence of an uncontrolled fire. In fact, there are so many false signals that monitoring center operators routinely call the source of any alarm to check whether there is a fire in progress.
Hello, Mr. Johnson. Yes, the alarm receiving centre. We've received a fire alarm from you. Is everything okay?
Residentials works really well. We get about 96% success rate with that. The commercial's a bit more difficult because the people who answer the phone don't always know what's happening.
The problem lies with the technology in traditional automatic fire detectors.
The sensors that are fitted to installations are not capable of discerning between different types of fires, and they can be operated by cooking, by steam, by smoking, by all sorts of things. And what we'd like to see is a far more intelligent system, a far more intelligent sensor that will be able to tell us what we're being confronted with at the scene and make a much more realistic decision about how we should respond.
One solution is a new style of multi-sensor fire detector. These respond to several different stimuli simultaneously, such as significant rises in temperature and the level of carbon monoxide, as well as the presence of smoke, to determine whether a fire has really started. This use of more than one indicator significantly increases the accuracy of the system's reporting and the level of confidence in the signals it transmits. This improvement does not compromise on safety. Occupants can still be alerted to a potential fire by an alarm tone generated from any of the individual sensors. If a multi-sensor detector is connected to a dedicated telephone line, the fire and rescue services can respond quickly and efficiently to automated signals, knowing the likelihood of this being a real fire is high.
Okay, if you just bear with me, I'll get someone on the way to it now.
False alarms are also significantly reduced, allowing the FRS to concentrate their resources on dealing with serious incidents.
FPA motorway services.
As the following examples show, multi-sensor alarms are much more reliable than traditional single-sensor alarms, and therefore more valuable to individuals, their insurance companies, and the fire and rescue services. Imagine a hotel. A tired guest is in the bathroom having a shower. They leave the door open, and within a few minutes, steam drifts into the bedroom and comes into contact with the single-sensor fire detector on the ceiling. On this trace of the detector's output, the red line maps the amount of smoke detected, whilst the white line shows the danger level, which will trigger the alarm on reaching 3. The steam hitting the sensor gives a high smoke reading, and it doesn't take long for the danger level to reach 3 and the signal to go to the monitoring center. Even though it's merely a steamy hotel room and not a potentially dangerous fire. Now imagine that this room had been fitted with a multi-sensor detector. Again, the red trace maps the smoke detected and the white trace indicates the danger level. This time though, there's also a green trace which maps the temperature. It's the combination of these readings that determines whether an alarm signal is sent, rather than triggering solely from the smoke reading. The sensor detects smoke when the bathroom door is opened and sees the initial rise in temperature, but as the temperature then starts to fall, it realizes this isn't a fire and the danger level remains at 1, preventing a false signal from being transmitted. Similar unwanted alarms can be generated by cigarette smoke. When cigarette smoke reaches a single sensor detector, it immediately prompts an alarm signal to be sent to the monitoring center, as if the room were on fire.
Hello, Mr. Fisher, it's the alarm receiving centre. We've received a fire alarm from you. Is everything okay?
The operator challenges the alarm signal and eventually discovers that this is a false alarm.
Thank you, bye-bye.
Even if the fire and rescue services have not been called out, time and money have been wasted. If instead a multi-sensor detector had been installed, it too would have reacted to the cigarette smoke and set off a local audible alarm, but its carbon monoxide and temperature sensors would not have been activated, so there would have been no alarm signal sent to the monitoring center. However, if the cigarette had dropped into a bin and set some paper alight, the multi-sensor detector would have seen a rise in temperature and the carbon monoxide generated by the fire, as well as the smoke. It would have both set off a local alarm
This is a fire alarm. Please move the building immediately by the nearest available exit.
and sent a response to the monitoring center, prompting an immediate call-out by the fire services. A single sensor detector would have also sent a signal to the monitoring center, but due to the high incidence of false alarms, it would have automatically been challenged, wasting valuable time and potentially allowing the fire to escalate. Industrial processes are also responsible for generating a large number of unwanted alarm calls. Welding, for example, generates smoke and dust, both of which are liable to trigger a response in the single sensor device, which thinks that a fire is started and sends a false fire signal to the monitoring center. Contrast this with the response of a multi-sensor device. It too will respond to the smoke, but because the carbon monoxide and temperature sensors are not affected, it will not send an automatic signal to the monitoring center. However, if a spark from the welder ignites something else in the workshop, then the rise in temperature and carbon monoxide would be detected, prompting an automatic response which should lead to an immediate call-out by the fire and rescue services. These scenarios all illustrate the same problem. Traditional single-sensor fire detectors often can't distinguish between genuine fires and false stimuli. This results in thousands of false alarms every year and the significant waste of the fire and rescue services' time and resources. They can also lead to unnecessary delays when dispatching appliances to real fires, while the alarm signal's integrity is checked.
Right, okay, so you're not able to confirm for me if there's any signs of fire? Would you know if the sprinklers have activated?
Multi-sensor detectors are far more accurate at identifying genuine fires, so reducing false and unwanted alarms and allowing the fire and rescue services to concentrate their resources on genuine emergencies. They cost little more than traditional single-sensor models and can be retrofitted onto existing systems and wiring, requiring little more than reprogramming of the alarm panel. Importantly, they can also be individually tailored to their environment. So a sensor fitted in a hotel kitchen can be set to react differently to one in a hotel bedroom.
That would mean that the activations that would come through we could deal with, and they're probably going to be the genuine ones, which we can get out to the fire and rescue services.
That will enable us to direct our resources much more effectively to where they should be. It will reduce cost, and it will make our public and our firefighters safer.
Grenfell Tower showed all too clearly the devastating consequences of a major fire. The overhaul and modernization of these critical, life-saving fire detection systems is long overdue. Multi-sensor detectors save time, save money, and will ultimately save lives.